Hi, welcome to C Sharp Essentials. We have put this course together to try and help people who would like to learn to program and to program with the C Sharp programming language to get to a position where they have the confidence in their abilities as a C Sharp programmer to continue at their own pace. Please understand that this is a journey. It's not a one-stop destination. You need to be prepared to join us in investing your passion and your time in this process. Please also understand that this is not a spectator sport. You're going to need to get your hands dirty. You can't simply sit and watch videos and expect to learn how to be an experienced programmer. You need to please try and follow the examples we're going to. In this episode, we're going to continue on our journey up on C Sharp development by learning more about things that we can do between the curly braces that we found in our first console app. So something a little bit more creative than just saying hello world on the screen is what we're trying to achieve in this session. And we're going to look at the concept of variables and data types and the typical flow of logical statements in our C Sharp console apps. So here is our challenge. We want to build a C Sharp app that is capable of converting from degrees Fahrenheit temperature to the equivalent Celsius, or centigrade if you will, if you're very old-fashioned. So Fahrenheit to Celsius is what we want to achieve. Now the great thing about this is not a mystical requirement. The formula is very, very well known, and basically what you do is you take the temperature in Fahrenheit, the F degrees, minus 32. Whatever the result of that is, you take 5/9 of it, so you multiply by 5 and divide by 9, and that gives you the temperature in Celsius. Very straightforward, very, very simple. Now the formula is shown in C Sharp syntax here to a large degree. So that the asterisk that you're seeing there represents the multiply operation. And the parentheses around F degrees minus 32 indicates that we want to override default precedence. We want to make sure that the subtraction happens before we do the multiplication and the division. Otherwise, they would happen first. So we're going to learn some very simple keywords, symbols and operators, and combine them all together to get our Fahrenheit to Celsius converter working. But we're going to start that by creating a brand new empty console app in exactly the same way that we did for our first default console app. For our second example in this session, we're going to do our conversion, create an app, a C Sharp program that runs in the console that will provide with a Fahrenheit temperature, and it'll give us the Celsius equivalent. So we're going to start right from the beginning again so you get used to the concept. We go to the command line, we go to our home folder, wherever it is we're working from, and we create a new folder in which to create our new C Sharp console application. Once in there, we create a new console app, use program main. Oops, lots of typing errors today. And as we'll recall, after that we can do an ls or a dir of that folder, and we can see that we've got our new program.cs file. Okay, so then we start code space dot in our folder, and we get Visual Studio VS Code showing up for us on our screen, hopefully looking something like this. As always, we get this really annoying AI nag, which I'm going to get rid of to free up some screen space. And I'm going to click on program.cs, and that gives us our default console app, which is where we're going to start. And that's all very well and good. There's nothing wrong with it. But I don't want to display hello world. I want to create an application where I am going to accept as input or take as an input value a temperature in Fahrenheit, and then I'm going to convert it to Celsius, and then I'm going to display both the Fahrenheit and the Celsius values in the output. So let's have a look at what I'm going to do on that. The first thing I need what is known as a variable, a storage place, a place in memory where I can store the value of my temperature in Fahrenheit that has the value that is assigned to it. So let's look at how I do that. What I do, I declare a variable using two facets. The first thing is I give it a data type. Now in this case it's a floating point number. What that means is it's a number, a numeric value that has a fraction or can have a fraction. Floating point, and I'm going to give it a name. All variables get a name, a unique name within our application. Degrees, I'm going to call this degrees capital F. This style of name is called Pascal case. Pascal case. And what that means is we use switching between uppercase and lowercase to make our variable names more meaningful. You also get camel case, where every word, camel case, where every word in the name starts with an uppercase letter, but we'll use those for other things. But for our what we call local variables because they are local to the scope within which we're working. Scope is the place between the starting curly brace and the ending curly brace. So I have my first variable here, degrees F, and I'm going to assign a value. I'm going to say that the degrees F variable is going to have the value of, let's say, 90 degrees. This value here, this numeric digits value, we call a static constant. Now I'm going to put a comment in here using the / syntax. / syntax is a comment, very important in C#, that says everything after the / is ignored, and this is assigning constant static value, or constant value, static value. You can put static in there as well. It's kind of tautological, but it doesn't matter. It's a static value. Can't change. It's a fixed value. Now I need to apply the formula we discussed in earlier content to convert from Fahrenheit to Celsius. And I need to store that new result value in another variable, which is going to be my degrees C variable. So I'm going to create another one here, another variable, degrees C, and I'm going to say that this is determined by taking my degrees F variable. You can see that that Visual Studio is helping me. It's predicting what I can type, and I can hit tab and all sorts of things. I'm not going to do that. I'm going to type everything explicitly to help you understand why I am typing these things. So degrees F minus 32 times 5/9 is my degrees C. So there's my formula. Notice that I'm substituting whatever the value is that is assigned to degrees F. It's currently 90. So I'm saying whatever that value is, less 32 times 5/9 will give me the degrees C value. So here I can say calculate the result, and then what we finally want to do is we want to display the resulting output. So I am going to use the console.writeline. We've seen console.writeline before, but I'm going to do something slightly different. Before we did something like hello whoops, hello world. But we don't want to do that. We want to say that the value in Fahrenheit is equivalent to the value in Celsius. So the way I'm going to do that is using a mechanism. I'm going to put a comment over here, use interpolated string output to display. And what interpolated string output means is the following, is I can say that I want to have a message that's going to be displayed, and inside that message I'm going to interpolate or substitute the values of the variables that I have, degrees F and degrees C. And the way that I do that, I put a $sign in the front of the quotes. So this is just an empty string right now, and I'm going to say that degrees F, close the curly brace, in F is equivalent to degrees C, close the curly brace, C. There we go. So let's have a look at that. I'm just going to make this slightly wider so we can see it all. Oh, I've got a typing error. Here's an interesting thing. The red squiggly line is saying you've got a mistake there. There's no such thing as degree C. It's not declared. You don't have a variable called degree C. And the problem is that I made a typo up here. You can see it's a great example of how VS Code is helping us to fix our own errors. So if I change that to degree C, which is what it should be, then now Visual Studio and the C# extension for Visual Studio Code and VS Code extension for C# are perfectly happy that everything looks correct in my my program.cs file. Notice, as we discovered in the first example, the black dot is appearing next to program.cs, and that's saying you haven't saved your changes. Really important concept. So we're going to save our changes. I'll hit Control S to do that. And now I'm going to start the terminal, go up to terminal, new terminal, and I can say .NET run, and we should see 100 degrees in Fahrenheit is equivalent to 32 degrees roughly in Celsius. And that is absolutely correct. That is exactly the result that we wanted to have. So, to review briefly, we created our simple application. Remember, it starts at the first curly, goes down to the last curly brace, closing brace, and we declared a variable which we call degrees F. It's a floating point variable. We're going to work with lots of different types of variables in future examples. This could be integer, it could be a string variable, but it turns out that floating point variables means that we have fractions potentially in our values. We've got another variable here called degree C, and instead of assigning a fixed value to it, we calculate the assignment by taking the current value of another variable, substituting that, so this actually ends up as saying 90 minus 32 times 5/9. Take whatever the result of that calculation is and assign it to this variable. Equal means assign. This equal symbol means assign. And then we display the output on the screen using this interpolated string output, where we substitute the values stored in our variables within the curly braces. We substitute into the space between the quotes, the double quotes, to get our resulting output string. Right, now we're going to take our simple Fahrenheit to Celsius converter and allow it to take input from the keyboard and display output to the screen, which we're already doing. We're already displaying the result to the console, but what we want to do now is, instead of having a hard-coded constant value of the Fahrenheit temperature, we want to allow the user to type in something at the keyboard, and then convert that to a numeric value, which we then convert from Fahrenheit to Celsius. In order to do that, we're going to use a couple of Command C# syntax variants that you'll see. We're going to use WriteLine, which we've used already. We're going to use write instead of WriteLine because it has a slightly different behavior, so console write instead of console WriteLine. And we're also going to use console readLine to capture a string of input from the keyboard and assign that value to a variable. Okay, so now that we've got our basic simple Fahrenheit to Celsius conversion app running, remember that we were converting 90 degrees in a variable to 32.2 degrees assigned to another variable. We discussed that variables have names and they have data types. And there's various different data types, and we'll cover that in a lot more detail later in this course. For the moment, let's assume that we know we need a variable, and we know that our knowledge of C# will enable us to select the correct type of data type for the variable that we have, in this case a floating point number, which is a numeric value with a fraction. Now, what we want to do is we want to extend our simple example so that we can take, instead of only working for the value of 90 degrees, we want to be able to type in something at the keyboard and use that value that we've typed in at the keyboard input, to be the degrees Fahrenheit value instead of the static constant. So what we're going to do is we're going to change our application slightly. We're going to declare a new variable, and I'm just going to call this keyboard input. Notice that it's a string. It's got a variable name, Pascal cased variable name, meaningful. The idea with variable names is you try to make them as meaningful as possible because they help you to understand your code in the future. Why did you have this variable? What was it for? So, and that's where we use Pascal case to use uppercase and lowercase switches to make the name of the variable more readable. At the moment, you'll see that Visual Studio Code has put a brownish squiggly underneath it. What it's telling us is that we've declared this variable. It's called declaring a variable. We've declared a variable, but it's not used, it's got no value. And it's not used at all at the moment. That's fine, we know that. Then what we're going to do is we're going to use the console.write, and before we used console.writeLine, but here we don't want to go onto a new line after our write. We just want to say, please enter the temperature in Fahrenheit, and I'm going to put a colon and end the statement here. If I'd used WriteLine, then this string would be displayed on the screen, and then a new line would happen, and then we'd start on a new line afterwards for the input. I don't want to do that. I want the input cursor to appear maybe after a space. So I've put a colon and then a space, and then that's the end of the prompt, or input prompt string. Now what I'm going to do is I'm going to use another console command. In this case, instead of write for output, I'm going to get a read for input. So I'm going to say my keyboard input is equal to console.read line. And I'm just going to, it doesn't have any parameters. We'll talk about what parameters means later. At the moment, what we're saying is we want to read an input line from the keyboard, and whatever was typed in by the person running the program is going to be assigned. Remember, that's what equals means. Assign whatever came from the keyboard to the variable called keyboard input. And because it's a string, it can accept any values, alphabetic, numeric, whatever, punctuation marks, it doesn't matter, whereas a float can only accept numeric values and fractions. Now what we need to do is we need to say, well, this assignment here, the 90, we don't want to do that anymore. Instead, what we want to do is we want to say that this is going to be, and here we're going to use some syntax that you don't need to understand or worry about too much right now. Just accept that it will work most of the time. You're going to say float.parse, and this is not a good way of doing this. There are better ways of doing this, and we will come to that later, but for the moment we're trying to keep things simple. So what we want to do is we want to convert whatever was in the keyboard input string, we want to convert to a floating point number if that's possible, and then assign whatever that value is to our degrees F variable. If something is typed in at the keyboard that is not a valid numeric value, we're going to have a problem. But assuming that it is a valid input, then that numeric input is going to be assigned to our degrees F variable instead of the constant static value we had previously of 90 degrees. As always before, remember, look at the top of your file. We can see the black dot there, says we haven't saved. I'm going to Control S to save my file, and I'm going to run the app. So now, instead of, don't worry about the warnings and things like that. Unfortunately, this is just too much information. It's a criticism I have, to be honest. We really don't need this right now. But what we do want is to look at the screen and see that this is the prompt string, the string that we said we wanted displayed on the screen, console.write. This is what we're getting. And notice that our cursor is waiting at the end of the line. And so let's type in 90 and hit enter. And there we go. So 90 in F is equivalent to 32.2 C. It works perfectly. This is great. And now, so if I run the program again, and I typed in, let's say, 120 and hit enter, then I get 48.8889 C. This is all really good. If I changed my statement here to write line and save the file and then did a .NET run down at the bottom, you'll see that the cursor is no longer at the end of this line, it's at a new line, but it'll still work. So I can type in 90, and there we go. 90 in F is equivalent to 32.2 in C. This is great. There is, however, a big problem with this. I'll change my code back first of all. So I was happy with the write, that works great. So let's go here and run into the temperature in F, and if I say what is 32, then it's 0 degrees C, which is absolutely correct. But what happens if I type in rubbish, garbage, into the input? Garbage. This clearly, the word garbage cannot be converted to a floating point number, a number that has fractions, or could have fractions. If I hit enter, I get what is known as an exception. This is an important thing. This word exception is important, and we're going to learn a lot more about it later. It basically says there is some fundamental error here, and that can't work. It would also happen if I, for example, just hit the enter key without typing in a value. There is no valid numeric floating point input in my terminal input and my keyboard input. So the conversion to floating point, this conversion from floating point to this floating point variable cannot work. And you see it's telling us that it's at line 13. There it is, an exception. It's at line program.cs line 13. There it is. So we know exactly where our problem is, and an exception says that we have got a problem with the way that we are using this code. And it's not a problem with the code. We know that float.parse works perfectly well if we have valid input. The problem is not our code, the problem is our input. There's a couple of really important lessons to be learned here as a coder. Never trust input. always assume that input from wherever it comes from a form, from a keyboard, from a HTTP input message, always assume that input could be invalid and check first to see if it's valued before you try and do anything with it. We're not going to do that in this example because it's way too complex for where we are. It's way above our pay grade right now. But let's assume that there is a way of mitigating these risks, and there certainly is, and we'll learn about that later. For the moment, what we've done is we've improved our simple app such that we can take a string input variable, convert it to a floating point value, and then perform the calculation. We've learned quite a lot in this very brief session, a lot of really important concepts that you will use over and over again for a long time. First of all, we used the .NET new command to create a new .NET app in an empty folder. That was important, an empty folder for a new app. We then learned that a C# console app starts with a main, static void main, this line over here, and then there's a pair of curly braces. And between those curly braces is the body of whatever it is that your app is going to do. It starts at the top by default and goes down to the bottom and then stops. Very, very simple concept. We've learned that we have variables. These variables are given names. They are places for us to store data until we do something with it, input or output. These variables can contain different types of data, strings, float numbers, which are in the real world we'd call them real numbers. They are fractions. They are numbers that can have fractions. We give our variables names. They're meaningful names, and they are typically in Pascal case, lowercase, uppercase combinations. We use the console read and write related statements that we've seen to get input from the keyboard and display output to the console, to the command line output. And we can use various operators like numeric operators, in this case multiply by, divide by, subtract from, and very importantly assign. We've got all of these operators that we're going to use in our C# applications from this point onward. So lots and lots of concepts that we're going to string together in our knowledge that grows our journey into the world of becoming a C# coder. Thank you for spending your valuable time with us. We hope that you found this valuable and that we are helping you on your journey to becoming a coder in the C# programming language. Please like and subscribe if you find this content useful, and share with anybody who you think would also like to benefit from our content. Also, please send us your feedback either in the comments section or by going to patreon.com/incremented and letting us know how we can do better. Please tell us what we can do to try and improve your experience with our content in the future. Thank you.